2.1 prime factorization. I can find prime factorization.
Can you guys find the prime factorization of a given number? Yes or no?
Yes.
Oh my God, you so can. Now, I think the most important part of this lesson is technically the vocab, which I don't say very often. You've got to know what a fraction is. Beyond just the fact that it's a division problem, it's part of a whole. You have to know what a prime number is. You have to know what a composite number is. And you can read all of these things. Prime factorization, you need to know what that means. And a factor tree, you need to know how they go together. How factor trees and prime factorization go together. In order to get prime factorization, you need to use a factor tree, right? So factor trees give you the prime factorization of a number. Okay, remember, a factor tree is a diagram, and you'll see them in a couple of seconds when we scroll down. Before we can really do prime factorization, we need to understand that all numbers have factors, right? And all numbers have two common factors. What are the two common factors? Are two factors that all numbers sort of have in common? Kind of a weird way of saying it. Toby?
One and their number.
One in itself, right?
Yeah.
So no matter what number you have, you can say, what are the factors of that number? You can say, well, one in itself for sure, right? So if the number is 40, 1 is a factor and 40 is a factor. If the number is 25, 1 is a factor and 25 is a factor, right? So every number has one in itself. If those are the only two numbers that the number has for a factor, we call that number a prime. Now, if it has more than one in itself, we call that number a composite. So, if I ask you to find all the factors, is there a way that we do it in this classroom?
Yes.
Yes or no?
Yes.
Yes, eyes are up here, right? We use factor pairs. So we did the number 12. And we list all the factor pairs, starting with 1 in itself. So 1 and 12. And then we just go right down the line. Does 2 work? Well, of course it does. It's an even number, right? 12 is an even number, so 2 always goes into an even number. So we found the factor pair 2 and 6. We tried 3. It worked. We knew we were done because when we went to the number 4, we already had it listed, right? And then if I wanted you to put it in order, you would just follow the U shape. And you would go 1, 2, 3, 4, 6, 12. Yes, no?
Yes.
And we got so crazy that we went to the number 600. And 600 has a lot of factors. And look at that U-shaped. Wow, isn't that cool? So we use factor pairs to find all the factors of a given number. And by the way, a factor is always what compared to the given number? Someone raise your hand. A factor is always what compared to the given number? I need more than just 4 people. A factor is always what compared to the given? Luke? Smaller than the given or equal, right? It's equal or smaller. And I think that was our cheat sheet. At least that's the cheat sheet I wrote down. And then factor trees. We've seen these before. Factor trees are taking a number and breaking it down into its smaller factors until ultimately you get to the prime factorization, which would be the prime numbers that multiply together give you the given. Is 2 times 2 times 3 12?
Yeah.
Yes. And do we write it as 2 times 2 times 3?
No.
No, we write it as 2 squared times 3. Because there are 2 2's, so we use exponential form if we can. If you can't use exponential form, then just leave it as is. 600, we broke that baby down. It took quite a while, didn't it? Every single time we found a prime number, we circled it. And then before we did it in exponential form, remember we list all of the prime numbers out, and we cross them off as we go. So we found a 2, we crossed off a 2. We found another 2, we crossed off another 2. We found another 2, we crossed off another 2. We found a 3, we crossed off the 3. We found a 5, we crossed off the 5. We found a 5, we crossed off the 5, right?
Yeah.
And then you use this right here to write the exponential form of the prime factorization for that number. Questions?